Hello everyone, this is me again, Maria Nanyarama, your student teacher from Central Mindanao University. I welcome you to my YouTube channel. So for today, we'll be having another topic for the volumes of solids of revolution, and now for the another method, which is the cylindrical shell method. So in the shell method, the slices are obtained by cutting through the solid that is perpendicular to the axis of rotation. When that happens, we end up with concentric cylindrical shells like this one. Also, let's understand how the formula for the shell method was established. So consider a representative rectangle that has the following characteristics, where our W here is our width or our thickness of the rectangle, and it with respect to the opposite axis of revolution. Now our H here is the height of the rectangle or its function, and our P here is the average radius. So as you can see in the figure, we'll just to locate that one. Okay, so now to find the volume of this shell, consider two cylinders. So we have this one. Recall that the volume of a cylinder is the formula for the volume of a cylinder is pi r squared h, right? So our outer radius consists of P plus W over 2. So that's the average radius for our shell. And for our inner radius here is P minus W over 2. So now for the volume of the shell, or the formula, we have the volume of the cylinder minus the volume of the hole. Here we have the volume of a cylinder. We have pi times P plus W over 2 squared h. So our R here, or our radius here, consists of outer radius minus the inner radius. So here minus pi times P minus W over 2 squared h. So we have to find the volume of a cylinder. So to find the volume of a cylinder, we have to subtract the volume of the hole. So we have here 2 pi times radius or average radius times height times width, or the average radius, height times thickness. So 2 pi here is the constant in the formula. So also we can approximate the volume of the solid by n such shells of thickness or delta r, height or h, and average radius or p. So we have here the integral or the summation. If we have to solve hand in hand, so we have to use the summation. So now in the easy process, so we have to use the integration. So now we have integral from a to b 2 pi r h dr. So for our horizontal axis of revolution here, we have v equal to integral from c to d 2 pi y g of y dy. So our y here is the shell radius or the average radius of the shell, and our y here or g of y here is the shell height. So it with respect to a y-axis, so dy. So now we have the vertical axis of revolution. So we have v equal to integral from a to b 2 pi x times f of x dx. So it with respect to x when the axis of revolution is on the y-axis. So the different here from the shell method from the other methods is that the axis of rotation, when we say the shell method is if the axis of rotation for the shell method is on x-axis, so the measurement lies with the y-axis. Okay, and for the washer and this method, the axis of revolution is on the y-axis, so all the measurement would be lies on the y-axis. So it's completely different from the other methods. Okay, so example, Find the volume of the solid generated by revolving the region bounded by y equal to x minus x cubed, and the axis x-axis interval 0 from 0 to 1 about the y-axis. Now we'll have this formula. So the volume is, or the solid is rotated about the y-axis. So all the measurement lies in x. So we'll have to find it with respect to x, or delta x. Now we have the function here, our height, and our radius here is delta x, or simply x. And of course, the limit of integration here is from 0 to 1. Okay? So here we have, because x ranges from 0 to 1, so the volume of the solid is, we have here the formula for the shell method. We have integral from a to b, 2 pi times x times f of x dx. Okay, so we have to substitute the given value. We have here 2 pi integral from 0 to 1, and our radius here still x, and our height here, or our f of x, is equivalent to x minus x cubed dx. So remember that our solid here is rotated around the y-axis. But then again, the shell method is different from other methods, and the axis of rotation is completely different. So now if we have to rotate, in the shell method, if we had to rotate the solid in the y-axis, so the axis of revolution is on y-axis, but we have to use it with respect to x, or dx, because all the measurement lies at the portion of the x-axis. Okay, now we have here 2 pi integral from 0 to 1 times x times negative x to the fourth plus x squared dx. And then integrate 2 pi, we have 2 pi times negative x to the power of 5 over 5 plus x cubed over 3 evaluated from 0 to 1. Now we have here 2 pi negative 1/5 plus 1 over 3. Then we have the final answer, 4 pi over 15. Now, around the y-axis, let's try around the y-axis, okay? The region bounded by the curve y equal to x squared, the x-axis, and the line x equal to 2 is revolved about the y-axis. So find the volume of the solid generated. Take the elements of the area parallel to the axis of revolution. So now we have here, it revolves around the y-axis. So the element, or the shell method here, is parallel to the axis of revolution. So we have here the formula, v equal to integral from a to b, 2 pi times x times f of x dx. So we have here, substitute the given value, our radius here, or our x here, still x, because all the measurement comes with the portion in the x-axis. And we have also here our height, or our f of x, is equal to the function. So we have here 2 pi integral from 0 to 2 x times x squared dx. So integrate x, so substitute x here. So we have x cubed, and then integrate, we have 2 pi times x to the fourth all over 4 evaluated from 0 to 2. So we have here the final answer, 8 pi. So for an activity, you can try it on your own. So find the volume of the solid generated by revolving the region bounded by the graphs of y equal to x squared plus y. So y equal to 0, x equal to 0, and x equal to 1 about the y-axis. So here, the solution. So our solid here is revolved around the y-axis. So meaning we have with respect to x. All the measurement comes or lies in our x-axis. So we have here our width or our thickness. We have delta x, or it with respect to x or dx. So our p here, or average radius, still our x, because our solid here lies with the x-axis. And finally, our height here is equal to x squared plus 1, or simply our function, our given function. So now we have to substitute it to the formula. We have 2 pi integral from 0 to 1 times x squared plus 1 dx. So we have here integration. We have 2 pi times x to the fourth all over 4 plus x squared over 2 evaluated from 0 to 1. And then we have 2 pi times 3 to the fourth, or 3 pi squared. So now let us have around another example, but this time around the x-axis. To determine the volume of the solid obtained by rotating the region bounded by y equal to cube root of x equal to 8, and the x-axis about the x-axis. We have this graph. If we'll have the graph, we'll have to find the limit of integration using graphing, or just have to solve it using a simple algebra. So for the given, we have here y equal to cube root of x, but our solid here is around the x-axis, right? Yeah, it's around the x-axis. So we'll have to solve for x from the function, original function. So we have y equals to cube root of x. Solve for x, we have x equal to y cube. And then we'll have, from the given, we have x equal to 8. And I'll just substitute x to x. So we have substitute 8 to x. So we have y equal to cube root of 8 equal to 2. So our y here is equal to 2. So here is the graph. As you can see, the solid lies up to 8, but it around the x-axis. So all the measurement comes from the y-axis. This time we have delta y or dy. So the unknown here is our height. So from the given, we have x equal to 8 here, and then y equal to 2. So the graph is nandyan lang siya sa 2, or dyan lang sa 2. And then we have to substitute the given value. So we have 2 pi integral from 0 to 2, which our y equal to 2 here is our limit of integration, and we'll have y times 8 minus y cube dy. Because then again, our y cube is this graph here, and our x here is equal to 8. Then we'll have just to subtract 8 minus y cube dy. Then we'll have this substitute y, or distribute y. We have 2 pi integral from 0 to 2 times 8y minus y to the fourth dy. So now we'll have, using integration, we have 2 pi times 4y squared minus y to the fifth over 5 evaluated from 0 to 2. So we have the final answer, 96 pi over 5 cubic units. So I hope everyone is having a good time listening. I hope everyone has learned what we had today. So that's all for today, and God bless us all.